Neel. Neel.
Neel.
Science rules.
Neel.
Ice is frozen water.
Neel. Steve. Neel.
Oh, hey, where do you guys come from? Anyway, I was just pondering the concept of buoyancy. Why don't you guys come along with me? The buoyancy of this tube is making me float, but if I do this, I sink.
Ah! I'm drowning!
As I demonstrated in the pond, some objects float in water, some sink, and some do neither. This is because of buoyancy. Objects that float are positively buoyant, and objects that sink are negatively buoyant. And objects that do neither are neutrally buoyant. The idea of buoyancy was created by the Greek mathematician Archimedes. This concept is summed up in the Archimedes principle. The buoyant force on an object, partially or fully submerged in water, is equal to the weight of the fluid displaced by the object. Since the buoyant force, Fb, equals the weight of the displaced fluid, it equals the mass of the fluid times gravity. Since mass equals density times volume, we can substitute this in to get the final equation. Buoyant force equals density of the fluid times gravity times volume.
Please stop the video at this time for an in-class activity.
Did you know that? Yeah! Gravity makes us fall! Now you know!
Ooh, hello, Skeletor. Oh, welcome back, guys. Oh, hey, Pete.
Oh, hey, Neel.
I haven't seen you since that flux capacitor convention back in Philadelphia.
Oh, yeah, that was a good time.
I was just telling these guys about buoyancy.
Oh, I love buoyancy. Did you tell them about what makes objects float and sink?
I have an idea. Why don't you explain it to them, Pete?
Okay. An object floats when it displaces an amount of fluid whose weight is equal to the weight of the object.
For example, the mass of this ping pong ball is 3 grams or 0.003 kilograms. When you multiply this by the acceleration due to gravity, you get a weight of 0.029 newtons. The ping pong ball displaces about 3 milliliters or 0.003 liters of water. Using the density, the acceleration due to gravity, and volume of the water, we can calculate the weight to be 0.029 newtons. Since this is equal to the weight of the ping pong ball, it floats. On the other hand, the mass of this lead ball is about 329 grams or 0.329 kilograms. When you multiply this by acceleration due to gravity, you get a weight of 3.23 newtons. The lead ball displaces about 25 milliliters of water, or 0.025 liters of water. Using the density, the acceleration due to gravity, and the volume of the water, we calculate the weight to be 0.245 newtons. Since this is less than the weight of the lead ball, it sinks. Thanks for explaining that to us, Pete.
Oh, no problem, Neel. Hey, guys.
Please stop the video at this time for an in-class activity.
Did you know that? Yeah! In an inelastic collision, the objects stick together. Yeah! Now you know!
So now you guys know what buoyancy is. But why does buoyancy occur? Well, as the depth of a fluid increases, the pressure increases proportionally. Check out this bottle. The lower the hole, the greater the force with which the water escapes due to the increased pressure. Pressure can be calculated using this proportion. Getting back on topic, this increase in pressure applies an upward force on the object, creating buoyancy.
Please stop the video at this time for an in-class activity.
Did you know that?
Yeah.
Did you go to the Oktoberfest?
Oh yeah, it was great.
Neel and I sure have bad odor. Yeah.
Oh yeah.
Now you know.
Hey there again, guys. Welcome back. During this last segment, we will be discussing how to find the density of an object using buoyancy. Let's go out in the field with my friends Adam and Alex to explore this concept.
Yeah. I am Alex Fergensteiner.
And I am Adam Van Buren.
We would like to teach you how to find density.
Using buoyancy.
Yeah.
Let us find the density of this hooked weight using the concepts of buoyancy. Yeah.
As you can see, the weight of the object is about 10.4 newtons. Yeah. When we submerge it in the water, its apparent weight becomes about 9.4 newtons. Yeah.
Yeah. When we add the apparent weight and the buoyant force and the actual weight, the sum of the forces equals 0. So if we substitute in the formula for the buoyant force, yeah.
We can rearrange the equation to solve for the volume of the object. When we plug in the values we found, we get a volume of about 0.000102 meters cubed. Yeah.
The density of the object equals its actual weight divided by volume times gravity. Using the weight and volume, we found that we get a density of 10,393.56 kilograms meters cubed.
Yeah.
Yeah.
That concludes today's episode. Thanks for joining us. I've had a great time, everyone. Catch you guys next week.
Neel.
Next time on Neel Nye the Science Guy.
Do aliens exist?
Me.
Yeah.
Dude, I don't think I can land on my feet.
Is there a hole in it?
It's like
Neel.
oh my god.
Why must we? By that Greek mathematician Archimedes.
Oh my. Yo, dude, what kind of airplane is that, dude? You see it?
Ice is frozen water.
Ow! Peter!
Neel.
I love buoyancy. Oh man, not again.